I think we're good to get started. And Nebulaworks, so thank you again for hosting and for helping us sponsor the event. This is officially the first user group in LA, so thank you for joining us. We really appreciate it. And probably the man that doesn't need much of an introduction, if you've been following HashiCorp, we have a special presenter today with Mitchell Hashimoto. I think he'll be giving an overview of HashiCorp and then going specifically into a little bit of Consul.
Yes.
Thank you.
Okay, cool. Hello. No, I'm not going to stand there, so let me just hide back here. That's really bright. Hey, thanks for coming. This is also the first SoCal hug I've actually been to. I've been to like the London hug way more often than this one, which is a weird reality to live in. But sometimes it's easier to get to London than Irvine, so I'll take it. So this talk's basically gonna be split into two major parts. I first want to talk about some of the updates, what we've recently released with our products, what's in the pipeline, what we're working on. That'll probably take about half the talk, and then the latter half, I want to talk about Consul Connect, what that is, what problem it's solving, and where that's going. And that is a new feature in Consul we just announced, probably in June, I think, so a few months ago. And that's about it. It's going to be pretty quick. Feel free afterwards to ask me any questions about any product. It doesn't have to be something I talked about here. So let's dive into it. So first I want to start with Terraform. I'm just going to go through Terraform, Vault, Consul, and Nomad. Probably not in that order, I don't remember. But starting with Terraform. So the big work underway, it's been underway for most of the year, so 9 months now, has been the .12 release. And that's about like 2 times longer than a release normally takes. But the reason why we've been working on it so long on the open source side is because it has such huge config improvements to it. We basically re-implemented the whole config language into it. It's mostly backwards compatible. There's some points we've blogged about what to look out for already, but it has some major wins. So you trade a few backwards incompatibilities, and I think anyone would trade them for what you get, which are things like for loops, repeatable resource blocks. That's dynamic configs. Null, that's actually just really embarrassing to put up in there because it's super exciting and it's just so simple, but being able to represent the absence of a config is a really big deal for writing reusable Terraform code. And there's about 10 to 12 different major config changes that are coming. So we blog about them. There's about 10 blog posts we give every week with examples of what it will look like. Any breaking changes, if there are any, not all of them have them. And yeah, so take a look at those. It's really exciting. A lot of people are excited about it. And the beta for .12 should probably be in the next couple months. And we're asking everyone to try it when it comes out and run a plan. Try not to run on a fly right away because we're not quite sure. There's some big changes, so be careful. And then on the enterprise, with tons of improvements. And then this second line is really important. Enterprise has historically been a UI-only experience, right? Like you buy Terraform Enterprise, you get onto it, and it's the UI runs Terraform, you work through the UI, and we've already released plan integration and apply integration is coming later, but we're integrating enterprise completely with the CLI. So for CLI users, you could hardly tell the difference basically. You still Terraform init, Terraform plan, Terraform apply. The output looks like what it looks like when it runs locally, but the output's actually being streamed from a remote runner. The benefits of those are that you don't need any provider credentials. You don't need to know how to off to AWS because the enterprise installation is doing that for you. It stores your state, it stores your secrets. There's basically no persisted state of any kind, secrets or variables or anything on your local machine. And so if you're a developer, it's going to feel like normal, and if you're a company, you get all the benefits of enterprise. So that's a really big deal ongoing. And then the last thing I just like to call out is providers, because providers are kind of what I think is one of the biggest successes that HashiCorp's had probably this year. And a lot of people don't realize this because a lot of people are so focused on one provider, like you use AWS most of the time or Azure most of the time. And actually about 18 months ago, providers were probably the biggest challenge or problem in the company at the given time. So we kind of woke up one day, found the sort of grave we dug ourselves with providers, which is that we had 76, I think it was 76 providers at the time. I think there's almost 100 today, but it was 76 at the time. And we had 2 provider engineers, and we were responsible for all 76. And so it was an impossible solution. Basically, we were shipping features as fast as we could, but we were basically just reacting, right? It was like, oh my God, AWS launched a new feature, implement that right now. Oh my God, GCP launched one. And it was just constant reacting, which isn't fun for anybody. Not fun for the community, definitely not fun for provider engineers, not fun for me when I hear it. And so we sort of revamped that whole program, and now 18 months later, HashiCorp as a company is fully responsible for less than, I think, 5 providers. We work on a lot more, but we work on them now in tandem with full-time engineers at the places the providers are built for. So for example, Google has 4 full-time engineers that work on HashiCorp stuff, and most of it's Terraform. Azure has multiple full-time engineers, and Datadog and other places as well, not just the clouds. They've committed to helping us maintain these providers. They control the release cycle. They can release whenever they want. That's a really big deal. So we're at the point now where our providers team is now a dozen or more, but we are now only responsible for less than 5. So that's a huge success and something that is less visible until you take a step back. And so that's Terraform. And then Vault. So Vault had a couple major releases recently, and now we're working on the next thing. So a few months ago, we came out with 0.10. 0.10, the major release really was that the UI was included in that release, which was a big deal because there was a lot of, the UI was an enterprise feature for a long time. We brought it down to the open source. And then otherwise, we've been really just focusing on battening down the hatches of where there's still theoretical attack vectors into Vault. And so one of the ones that a lot of our users and customers pointed out was this idea of root key rotation. So Vault has had the ability since 0.1 actually, to dynamically generate database credentials for you and a lot of other credentials, but this was databases, where if you need a, let's say MySQL username and password, you would ask Vault, and at the moment you ask for it, it generates you the credentials that are unique to your user, and this has a lot of benefits. They're short-lived. When you're given a lease and when that expires, we drop the user and all its connections, which is nice. But also if there is a breach or anything, you could look at the user who had the breach and you could trace it back to a very specific process that had to be breached. And so there's a lot of benefits here, but one of the theoretical attack vectors that was discovered was that you have to give Vault a super user to create these credentials, and the person who gives Vault the super user theoretically had them at one point and contend with only a few databases, and in the few months since then we have support for almost every database backend now. In one specific direction from a roadmap perspective, an enterprise one another. We do that periodically from the roadmap. Sometimes they're super aligned and sometimes they're not. But for 0.11, the open source really focused on ease of use. So we really heard from our community and our users that Vault could do anything. Vault has thousands of features. It's really pluggable. Its security story is really good. It has a lot of compliance and audits associated with it. It's like they trust the security of it. It solves their problems. They know it does. But it's really, really hard to learn how to use it. That's what we were hearing, right? And so that you don't just solve that in one release, but we started moving towards that. And what we focused on from the open source side was this ease of use. So one of the features we launched in .11 was contextual help in the UI. So this, I think .11 only came out a few weeks ago, but now if you use the UI, which is part of open source, whenever you're on a page, there's a little icon in the top right. If you click that icon, a sidebar, a drawer rolls out, and the drawer will give you help for whatever page you're on, and it's contextual. So if you're on the page where you're configuring an AWS auth backend, it'll actually link you to videos about the AWS auth backend, the actual reference docs about it, the API docs. It'll give you all the information right there. And so this is really meant to guide you wherever you are towards, help. And so this is starting with that. And we're going to keep working on that education going forward. There's actually going to be a lot of new video and guide content coming out in the next couple weeks here. And then on the enterprise side, the really big feature was namespacing. And so the most common way we see Vault deployed for enterprises is that it starts with one team, and then multiple teams sort of hop on board with their own clusters, and there's like 4 or 5 clusters in the company. And then central security or central ops finds out about this and decides that this needs to be a central service. This needs to be a single thing so that they can enforce policy like your database passwords have to be rotated every 30 days. How could they enforce that centrally? And so they want to take control of Vault. And so namespaces are a way they could do that. So what namespaces let you do is have a central Vault cluster, defines policy like if you use a MySQL backend, the passwords have to be rotated every 30 days, but then give every single individual team their own namespace. The namespace, it feels like you have pseudo access. You could do administrative changes, you can mount backends, you can mount plugins, you can do all this stuff as long as it's within the parent policy. And it's arbitrarily nested, so there could be central security that has their main policy, and then there's engineering, and they have a policy, and then there's product A and product B and product C, and they can just keep, the namespaces are nested, so you could keep having these basically sandbox, it's multi-tenancy, right? You could have this multi-tenancy in Vault. And with not new, but enterprise also has all. The expected next version of Vault is 1.0 if everything goes right. And the way we do 1.0s is that we never add features in 1.0s. 1.0s are always a stability release. So the team really for the next few months currently is focusing on closing issues, fixing bugs, removing any deprecations, so just taking those out of there, out of the code base, and cleaning up. So that's a lot of 1.0 readiness that's sort of happening. And then adjacent to all this, that doesn't affect core, just as an adjacent project to all this, there's a big Kubernetes effort spinning up around Vault. And for those who may have seen or may not have seen, in the past couple weeks we've announced a lot of Consul stuff with Kubernetes. The Vault stuff is now underway as well, and that's going to include a bunch of stuff. So we'll support an official Helm chart for installing Vault on Kubernetes. We're going to have a variety of ways to expose secrets to the kube cluster and pods in general. And so we'll talk about that more later. But we're really trying to integrate much more natively with kube. We're also working with other people like Google and Microsoft and others to do more core kube work with Kubernetes or with Vault. We're not doing that so much as Google, but one of the efforts, for example, underway is we're trying to make it so that it's a first-class feature of Kubernetes so that you can encrypt your secrets with Vault. So basically you have the default option, which is secrets are unencrypted. They're called secret, but they're unencrypted, they're an etcd. Or you have the option where if you have Vault, you can point it at Vault, and there's no change to the user, it's just a normal kube API, but actually all your secrets will be encrypted by Vault. That's a work in progress, but underway. Okay, and let's talk about Nomad. So Nomad is doing really well. So Nomad has 2 really big things that are exciting. So Nomad's finding sort of the most popular use case for Nomad we're finding is really high performance batch workloads. Nomad is a really, really, really fast scheduler, and so it's most commonly used in highly dynamic scenarios where nodes are coming and going, and when you're throwing a ton of workloads on it. So as an example, CircleCI blogged a year ago where they use like Kubernetes for all their web-facing backend services that don't change very often, but all CircleCI jobs, for example, run on top of Nomad because it's just a lot of load, a lot of batch. You want fast scheduling. So Nomad's finding a place for that. So a lot of the features, a lot of requests we're getting are kind of focused at that. So there's 2 really cool features that are underway. One is device scheduling, which is primarily GPUs, but we're also going to support FPGAs because some quite large users of Nomad are doing all their machine learning workloads. They want to do all their machine learning workloads on top of Nomad, and they want really good GPU resource scheduling. And then there's another company that I don't actually know what they're doing, but they need to schedule everything onto FPGAs, and so they want to do that. So we're enhancing Nomad with a generic way to basically schedule onto any device that's attached to a node. So you could have multiple GPUs, you could have TPUs. It's the coolest, least used feature of Consul, least known feature of Consul. It's called network tomography, and it basically lets you, for any two Consul nodes in the world, even in a multi-data center setup, it'll give you the round-trip time with a really high degree of accuracy, like 99% degree of accuracy. And we do that basically for free. It piggybacks on top of the Consul protocol that we're doing for health checking anyway. Doesn't introduce any new load into your cluster. We just know that information for free. And so there's an API where you could ask for the latency between any two nodes in the world. And so the way Nomad's going to use this is maybe obvious, but you'll be able to actually create affinities where you'll be able to say, I would like for this job to be within 50 milliseconds latency to the database, or things like that. Whether that's hard or soft. Like hard means it has to be within that latency. Soft is try to be within that latency. This is really important for the niche sort of Nomad is serving, where one of the examples is render farms. Render farms often have petabytes of data kind of strewn about all over the place. And if you could actually render those frames closer to the data, you could actually save. We have a user who has saved thousands of CPU hours by doing that, by using, they're actually not using Nomad, they have a custom C++ scheduler but on top of Consul network tomography. They're maybe the only user in the world, we're not sure. So that's being worked on, and then the last thing is preemption. And so preemption, of course, is just if a higher priority job comes in, we'll stop that job. And this sounds really basic. We've actually been talking about preemption for multiple quarters. This got punted actually all the way back down to our research team, and our research team is a cool group of people that are actual ivory tower PhDs. And basically, we got to preemption. We did a quick survey as engineers over the literature and realized that preemption is a really, really, really hard problem. It's one of those problems where you choose what properties you want and you lose on the other one. You can't have everything. And so we punted it out to our research team to give us better options, basically. And that's still a work in progress. And the challenge with preemption, to put it in a nutshell, is choosing which job to kill. It's a core issue of even OS schedulers. Like the kernel out of memory killer is probably the worst, that has the most esoteric options to tune of all time. And so we don't want to do that. And so we're trying to figure out how do we pick which job to kill. We know we have a lot of options, so we'll implement it by 0.9, but that's underway. And then the last thing is just the UI. The UI for Nomad is really good. It's one of the things that catches a lot of people's attention. It's completely real time. Everything about the UI is updated. If you show the list of jobs, there's all the CPU, memory, network sort of meters. They're always updating all the time. If you do a rolling deploy, you can actually watch the full status in a single dashboard of the rolling deploy, how it's progressing, when the next one will go out. It's a really powerful thing, and Nomad was a really hard project to build a CLI for, and the UI really shines as probably the right way to use a product that's this complicated, because the CLI was tricky. And so I just want to call that out, because if you're using Nomad, you should definitely spin up the UI. You just have to run Nomad UI as a CLI command, and you could run that with any identifier in Nomad, and it'll know what you're talking about, because our identifiers are all unique. So if you give it a job, it'll open up your browser to the job. If you give it an allocation, it'll open up the allocation. You get a deployment, it'll figure it out. So the UI is really easy to use and also really seamless with the CLI. Okay, and the last product I want to talk about is Consul. So Consul's been moving quite a lot. Earlier this year, we had the 1.1 release. That's probably March or April. In that, we had a new UI. I like to call this out because we hadn't touched the UI code at all for 3 years. And it was still working, it was great, but it didn't support a lot of the newer features, and it looked obviously outdated. We shipped the new UI in 1.1 and supported both, and in 1.2, we got rid of the old one. So there's a completely new UI. It looks good, but it also supports way more features. So you didn't really give up anything. You gained everything. And we worked with a lot of users to make sure that they'd be happy. We worked with a lot of old UI big users. In 1.2, we released Connect, which I'm going to talk about in like 2 minutes, so let's just skip that for now. And then future stuff, what we're currently working on in the Consul project, there's a lot of Kubernetes work going on. So to recap on that, because I don't expect people to have read the blog post that came out like a week ago, but there's a Helm chart that we announced. Actually, we released that publicly yesterday, but there's a Helm chart now for installing Consul. That's officially supported by us. We'll fix bugs, things like that. We're doing a lot of work around syncing services. So one of the top use cases for Consul in a Kubernetes world that we're reaching with customers is the challenge of discovering and connecting to services that are outside the Kubernetes cluster, or vice versa. How does a service outside the Kubernetes cluster actually talk into the Kubernetes cluster? And so, obviously, Kube provides services. They're great. Like, that's what you want to use. You could manually set up sort of external services and things, and basically what Consul does that for you. You use to access the service. Feels like it's built into Kubernetes, but you're talking out. And then for non-Kubernetes users, you use Consul DNS like normal. Feels like a normal service, and you're talking into the Consul cluster. And so that's one big thing that's coming. And then the other thing is Connect integration, so making it so pods automatically use mutual TLS everywhere, which is similar to something like Istio would do. Again, the benefit of Consul is this will work in and out of the cluster equivalent. So you could be talking, you could use a service discovery, be connecting to something that's out onto your on-premise data center. You're still getting mutual TLS, you're still getting the Connect benefit. It just feels like a normal service. And that's really what we're trying to do with Consul, is make it pretty much invisible to the end user or developer that's working on top of Kubernetes. We want it to be glue underneath. On the Connect topic, we're integrating with Envoy. So right now we have a built-in proxy that you could use, and that's pretty much it, more or less. And then we're going to support Envoy in the next version, so you'll be able to use that for production workloads. There's a lot of ACL improvements. So the ACL system is difficult to use for a lot of reasons. One of the biggest ones is that the policy identifier is actually also the token. There's no abstraction there. So if you want to create multiple users with the same policy, you have to create it multiple times, actually send the whole document. One of the most basic things we'll do is split that up, so there'll be named policies, and then you'll create tokens, users of that policy. You'll also be able to protect a lot more and be able to do exact matches. Overall, it will be much, much easier to secure Consul. And then in enterprise, I think audits actually got pushed out a little bit farther, but they're on the way. But in the short term, we're going to do multi-DC connect. So you'll be able to do the mutual TLS connections across data centers. Cool. And that's Consul. So now I want to just give a quick overview over Connect, why we built it, how it works. This is going to be pretty high level. I'm not going to show any terminal samples or configuration code samples or anything. There will be some diagrams, but that's about it. So the problem is really the problem of breaking up a monolith into microservices. So when you start with a monolith, there's a lot of problems you don't have. And the problems you don't have really is that everything is in a single process space. So there's not a discovery problem. Like if subcomponent A in your monolith wants to talk to subcomponent B, it's a public class. It's an exported function. However you want to do it, it's just there in the memory space. You just call it. There's not really a discovery issue other than knowing the name of it. And you get security and protection as well through public-private modifiers and things like that. So if you don't want anyone talking to B, then you make it private. If you want only D to be able to talk to B, then you learn how to pass it in a certain way. And so you have a lot of benefits to monolith, but there's also a lot of downsides. And this isn't going to be like a why microservices talk, so you could go find that out yourself. But things like if you want to ship an update to D, you have to ship the whole update, so that's a little bit harder. You got to test the whole thing. You want to move faster, so you kind of want to split them up. And you also want to scale separately, so you want these to be separate. So most people start looking at microservices. This gives you a smaller surface area over each component, ton of benefits, like I said. But it does introduce new problems. You trade the problems. You solve some things and you introduce some new things. One of the first things you introduced is the discovery problem. So now when A needs to find B, it's not so simple. You can't just know the name because that could be on a different host. It could be on a different port. You need to know a bunch of information about how to access it. And so the first thing you have is this discovery problem. The next problem you have is a configuration problem. So when you have one big monolith, it's usually one big monolithic config file too, giant a XML file, JSON file, whatever. It's one big file to configure the whole thing. Synchronizing that file to make sure A and B are updated at the same time, pretty easy because it's atomic. You probably have less servers if it's a monolith because you're smaller, theoretically. And so orchestrating the updates across the servers, easier. And then you start breaking out into services, and now you have, each one probably has some config file. You have to synchronize configuration in some way. You want it to go out reasonably fast. You don't want A on V1 of the config for an hour until it gets to V2. You want it to be pretty quick. So this starts to become a challenge. And then the third challenge, which is really part of what Connect does and what I want to dive a little bit deeper into, is the security problem. Back to a monolithic world, the traditional way to look at security is to break things down into three separate sort of zones. You have the outside world, where everything is scary and trying to hurt you at all times, and so you have that outside world. You usually have a load balancer and a firewall, so these dotted lines are firewalls, and then you cross through the firewall, and you're generally pretty trusted at this point. You're safe. You can talk to the monolith, you can do things, and then usually there's a third security tier, which is the data. So you usually put one more firewall in front of the data, who could access the data when, and then you have the data tier in the back. It's the most trusted zone. And this is pretty simple. This is good. This is easy to understand. But a really quick sort of problem you get into with microservices is it's not so easy to draw these boxes anymore. And this really comes down to the problem of segmentation. Segmentation is the idea of splitting a network into multiple subnetworks that have their own rules of who can talk to who. And so this is done in a variety of ways. There could be firewalls, there could be VLANs, there could be SDNs. There's a lot of ways to do it. But one of the things about it is that it's very coarse-grained. So the network has no idea what applications are running in it. It's just the identity and everything. The security is just based on an IP address. Whatever's in that IP address could talk to whatever the firewall says it can. So it's very coarse-grained, and so you usually end up with a lot of them. You end up with a lot of them with few applications in each of them, or you end up with very permissive security. Like let's make the security easier, the firewall rules easier, so let's have less segments and just put more applications in that group. You choose one. And again, in the new microservice architecture, it's hard to draw these dotted lines. It's hard to draw the firewalls, because if we imagine that this is the access pattern of our services, this is what they actually want to talk to, A might have to go to B, but A doesn't go to D. C and D are bidirectional. They request things from each other. B goes to D. You have these arrows. Then you have to draw firewalls between them. And this is what a lot of companies try to do. So the most common thing we see is people say, okay, the way we solve this is let's put the firewall between everything. This basically turns into however many firewalls that is, right? 8 or whatever it is. And then you do rules for each individual one. And this can work with 4 services. It could work. I mean, I know it works. I've seen it work with 4 services. The challenge with microservices is that this is usually where you're heading to. You don't go into microservices because you have 4. You go into microservices because you expect to have 100, right, or 1,000. And so even if you're at 4 today, this is your future in the very short term if your microservice adoption is successful. And if you have this, then good luck reasoning sort of about the firewall rules and all this. But also, it starts to get expensive, and sometimes literally expensive. Like sometimes it costs more money, but also just expensive in terms of knowledge. Like how do you think about? How do you understand this? Like it's really hard. And so this isn't theoretical. One of the people who talked at Hashi Days and publicly, and one of the things we talked about was how Consul helped solve this use case for a very, very large company in London. So they were moving from on-prem to the cloud. On-prem, they used network segmentation everywhere using F5 load balancers. They actually used those in between all their services. And then they moved to the cloud. You can't bring your F5 load balancer subnets only for the purpose of network segmentation. A good use of multiple accounts is billing. A bad use of multiple accounts is network segmentation. And so they had this problem. They wrote a bunch of tooling to automate the setup of it. And they all saw their on-prem F5s too. They were not, they're in a transition period, so they have both. And this was the slowest part of their deployment process, because whenever they wanted to deploy a new one of these boxes, it had to go to the security team, which had they actually had a little Excel spreadsheet with all the firewall rules for their entire data center, and they would enter the new one, run a bunch of macros, a bunch of other stuff to figure out if it compromises anything else, and it would take time. And no one wanted to say yes to that Excel spreadsheet row, right? That was a risk, a job risk. To say yes to adding a spreadsheet, it was easier to say no. So this became the bottleneck. They were like, we could write applications fast, we could spin up infrastructure fast, we're in the cloud, but it's more expensive than on-prem because we have all this overhead now. And so what we sort of introduced them to was the idea of service segmentation. So I'll explain that. So service segmentation is this idea, which is what you'd rather do is draw little boxes around individual services rather than the network itself. And so you'd like to be able to say these rules that A could talk to B, C could talk to D, and D, the bidirectional rule down there. And then you'd also like to be able to do the other boxes, say A could talk to C, B could talk to D, and it doesn't affect the other ones. This is how you easily like to express these rules. This becomes much easier to understand because if you're the publisher of D, you want to deploy D, and you're talking to the security team, the question then basically becomes, and you don't need to think about, how does this relate to our networking? How does this relate, what IP are you going to be on? What account are you going into? Like, those questions don't matter anymore because you're focusing on the service identity. And so, I'll jump back into Connect in a second, but these are really the three major problems that we identify for adopting microservice architectures. Before you get to problems like tracing, before you get to observability, debugging, like if you want to get there, you really have to solve how do you find the service, how do you configure the service, and how do you secure the service. And this is basically what we consider the fundamental requirements of a service mesh. If a service mesh provides something like tracing but doesn't provide security, then you're missing a fundamental piece. And so this is how we like to break things down. We're very sort of, structure-driven sort of thinkers, and so thinking things this way is really important because it also guides our products. So like to solve the discovery problem, you could have DNS. If you don't have a security problem, you don't have a config problem, ignore them. You could just use DNS directly. They're not inseparable. If you have a configuration problem, we have a KV store built in. And then finally, with the segmentation problem, we introduced Connect. I thought I just had. So you either end up building this and making these pluggable, which is possible. I mean, totally, you could do that. But we felt we could just build a better solution because what we're trying to solve. So, you could say like it's not Unix-like or anything. I never claimed it was. But each of our products really aims to solve a specific problem, and the problem Consul solving service mesh. It's not the problem Vault solving. So then let's look at a few slides of what it really looks like. So what Connect does then to solve the segmentation problem is it gives you a way to have secure service-to-service communication with automatic TLS encryption and identity-based auth that works anywhere. And so we'll go over these bolded words to show you a diagram of what that looks like. Here's the old world. Let's say the gray is the old network segmentation world. The pink is the new service segmentation Connect world. So over this world, you would have two IPs. You would have a firewall in the middle, and they would connect generally over plain TCP. It certainly doesn't have to be, but for reasons I'll talk about, it usually is plain TCP. In a Connect world, you still have, so you have these hosts, they still have IPs. That's just there to show you that obviously they're running on a network somewhere, but the IPs don't matter actually anymore. What's more important is you have visibility into the actual services. So you know one IP has an API and a web server, one has a database, and the actual rules, nothing in there. And then you make a connection using mutual TLS. And the mutual TLS gives you both identity, encryption, and authorization. So that comes, and you can see this is done on purpose, that the arrow is sort of outside the box, and the arrow in this case is going directly into the service. So this is directly connecting to it, and that's to show you that you can also have a rule that says that the web service can't matter. And the IPs not mattering is especially important in a scheduled world. In a world where you're running something like Nomad or Kubernetes, you definitely don't know, really, what the IPs are at any given moment, because the scheduler might decide to put it here, they might decide to put it over there, and you don't want to worry about IPs. So that was another issue. Going back to this customer that we had that had thousands of VPCs, was that they couldn't adopt schedulers. They were blocked from adopting things like Nomad because their security story underneath wouldn't let them. They basically would have had to run one Nomad cluster per VPC or subnet or something. I mean, it would have been awful. It would have been really, really expensive. And so this is much more attractive to them. So the way Consul does this is really 3 major features packaged up in an easy-to-use way. There's a service access graph, a certificate authority, and a pluggable data plane. The service access graph is how you define what services could access each other. And it's a graph because it's directional, right? A to B, B to C, you could actually create a graph of who could talk to who. To do this in Consul, what it's called, the ACL is called an intention. It's an intention for one service to talk to another. You could have both allow and deny-based intentions. We allow for both approaches. And what they say is the source and destination service. And so this is, again, the service, not the IP. This makes it scale independent. And so what I mean by that is firewall rules, because they're IP-based. If you have 5 web servers and 10 databases, that's roughly 50 firewall rules if you're doing IP, like specific IP. If you're not doing CIDR blocks or something, if you're doing specific IP, you get a combinatorial explosion of firewall rules. And so spinning up another database on a different host has a security thought to it. Again, unless you use CIDR blocks, but that has its own complexity of how do you get every single service that's on CIDR block. And don't say IPv6. I mean, that's a fine answer, but it's let's just ignore that for a second. With these rules, you could have any number of databases and any number of web servers, and it's just web server can talk to database, right? That's one rule. This, more than just the understandability of that, this has actual technical implementations, which is that all the client nodes in a very, very large cluster cache the rules on every single machine. And we could do that because there's so few of them. It doesn't matter how many machines or services you have, there's relatively few of these compared to firewall rules. So we'll just distribute and sync them everywhere. And the reason we do that is for performance on the edges. So that's really a really important feature. And to set up the intentions, you could do that with pretty much anything. We have a CLI to do it, an API, UI, Terraform. They all set the same stuff and see the same thing. So you could use whatever you want. Okay, so then the next thing is a cert authority. So you defined who could talk to who. How do we know who's talking to who? How do we do that? How do we get more security? How do we get encryption? And the way we do that is TLS. So all of the security in Connect is basically based on TLS. TLS is obviously a well-adopted protocol. It also has this property that we really liked, which is that TLS was designed for a wholly untrusted network, right? Like TLS was built to secure 2 connections between 2 machines and you to be able to safely send a credit card number over it, where how can you trust any number, any of the machines between you over this network that anybody can join, anybody can advertise any routes to. It was built for a zero trust network. And that's really what we're trying to encourage people to have in their own data centers, is a zero trust network where only the service endpoints are trusted, right? And so TLS is a really good choice, both technically and philosophically. And the 2 properties it gives us are identity and encryption. So the identity comes from the certificate, and the encryption just comes from the transport protocol. And the biggest problem with certs generally is generating them, managing them. And so if you recall back in the slide where I showed you the gray and the pink and the old world and new world, in the old world I said connections are generally plain TCP, even though they technically don't have to be. And the reason they're generally plain TCP is because people usually don't want to manage certificates. It's hard to manage certificates. So it's a whole different system you have to sort of build and think about. And so with Consul, it was really important that we solve the cert management problem. And so to do that, we built cert management as an API directly into Consul that Connect uses. But of course, we don't want to itself a pluggable. So you could, out of the box, you could use the Consul CA that gets you up and running really quickly. For production usage, you probably have more stringent corporate requirements, or you want to use something like Vault. So you could actually bring your own CA provider. We of course integrated Vault. That's sort of a bias that we have, but we are making this totally pluggable, so you could bring any other CA provider you want. And the way this looks, the way this works, is that when a client spins up, it generates the key pair over on the client. So this is an important sort of property so that we distribute entropy across the cluster. If we had 35,000 nodes and they were all asking for a CA certificate at the same time, then it's very, very likely the server will run out of entropy and you'll generate poorly formed certificates. So we generate all the key pairs on the client. They send a certificate signing request, just like when you're trying to get a normal cert, over to the server. And the server, if it's the CA, will sign it and return it. Or if you have a pluggable CA provider, will then forward it to that CA provider to sign it. When you use a CA provider, it's extra secure because this is the only thing that has a signing key, right? Consul actually never has the signing key, so that's an extra level of security you can get. And then finally, the next hard part is rotation. So you've got your certs out to all these machines. In an ideal world, you don't want those to live very long, because the longer the cert lives, the higher the chance that someone else gets the cert and can masquerade as you. If I find the web server certificate and private key, then I could go around making requests acting like the web server. And if I have access to billing data, I could theoretically ask for billing data with the billing service thinking I'm a web service. So you want to make this a very short-lived certificate, which is the next challenge in management, because that's complicated. You have to generate a new one, you have to serve both for a period of time, and then you switch to the new one. Consul does this all for you automatically. By default right now, I think our TTLs are like 3 days, I want to say, on the certificates, but the idea is that could be pretty short. I mean, that could be on the order of minutes if you wanted to, and it's totally fine. And a funny story about that is we built rotation in, and when we were testing rotation, we thought it was broken for a long time, but it was for the day we thought it was broken. It ended up was working, but it was rotating all the servers so quickly that we couldn't see the rotation happen. And so the rotation's super quick. You could basically rotate 1,000 node cluster, and it just happens instantly. And that includes the overlap period. We actually do a standard during the rotation. We cross-sign the CA so that both the old and new servers are allowed, and we only switch to the new one when we're sure that all the old ones are gone. And that all happened so instantly that we didn't realize it was happening. So we'll rotate. We'll also rotate across providers. So if you're switching from the built-in CA to Vault, or let's say you're switching from Vault to another proprietary provider like Benify, if you're switching CA providers, we'll also rotate it cross-sign so that both the Vault and the new one are allowed for a period of time until the old one's gone, and then revoke all those out. So that's all handled for you. It makes certificate management super, super easy. Equally important is the format we chose. So we chose the SPIFFE format for the standard X509 certificate. This is important because this is the standard out of the CNCF that multiple systems are starting to adopt. And because it's SPIFFE, Connect services could send their client cert to other services that aren't in Consul, aren't known by Consul, and potentially connect to them. And likewise, other non-Connect services can connect backwards into Consul, and we could accept connections from them. So those intentions that I showed you, you could do service A to service B. We also support a URI, like a SPIFFE URI to service B. So the source actually doesn't even have to be in Consul. The source could be an arbitrary SPIFFE identifier. The main system where this interoperability is nice is Istio. So Istio uses SPIFFE everywhere. So you could actually allow connections with mutual TLS with authorization into Consul from Istio, and Istio doesn't know it's talking to Consul, and vice versa too. Consul can talk out to Istio clusters, and it doesn't carry anything else. Okay, the last thing is the data plane. So it's really important when talking about any service mesh to explain and understand the differences between the control plane and the data plane. So the control plane in a service mesh is the thing that's defining all the rules for connectivity within your cluster, basically. Who could talk to who, when, how, that sort of thing. The data plane is the thing that's actually responsible for brokering those connections, the thing that's in the data path. And these are usually things like proxies that are like Envoy, for example. So there's a difference between who's the configurator, who's actually building the configuration, and who's the one consuming the configuration. Consul is 100% sort of squarely in the control plane side. We are just trying to manage the permissions, generate the certificates, generate all the configuration that the data plane needs to do its job. And we ship that out via APIs. Anything can integrate with that API. So you could bring in Nginx, you could bring in HA proxy. We're working with those folks right now, and that'll all work. And so with the data plane, like I said, you get a local Consul API for all the service graph, the certificates that you can just integrate with. And there's two options you have. So you could run a sidecar proxy. So this approach will run a proxy next to your application, and this makes it so that that application doesn't need to know about Connect. It doesn't need to modify itself either to deal with Connect. It can send an unencrypted connection to the sidecar, which is hopefully in its own isolated network namespace and its own sort of security enclave of sorts. The sidecar proxy actually wraps it up with the client cert in TLS, talks to the remote service, verifies it, authorizes it, makes the connection, and any data back is unencrypted and sent back, right? So it's proxying the data in between, makes it really, really seamless. This is the recommended way to deploy this stuff. We also support native integrations, so it's just basic TLS with one callback to authorize, right? So it's pretty simple to integrate. We have a Go SDK for doing this for Go services, and if you're using like a basic HTTP server, gRPC server, or something in Go, you could integrate Consul natively with one or two lines, not counting the import. That's really, really easy. And this should only be used for high performance cases, where the case more security sensitivity. The case where you never want the unencrypted connection leaving the process space, or the case where you don't want to deal with the couple extra network hops to make that connection happen. And so we never ever recommend this as the first thing. You should just run it with the sidecar first to make sure it works, to test it, go. And if you need performance, you can go to the native. It's highly unlikely, even with the sidecar proxy, it's all local, it's really fast. Like loopback connections on most operating systems are optimized to not go through the network stack, so they're already really fast to begin with. So the sidecar proxy is probably enough, but we do have a few hypersensitive users, so we offer the other one. And native integrations are also super important for things like serverless, right? Like serverless, if you're running a direct one binary or something, sidecars become really, really heavy in a serverless. We used to joke about the weight of VMs to containers and people laughing at the size of some Docker images. It's like if you go to serverless, it happens again, and you laugh at the size of the container, right? So as you get really, really small, these native integrations also become important. And that's it. So that's the overview of Connect. So thank you. Woo. Questions, Brent? Sure. Sure. Just tell me about time. So, any questions? Nice. Okay.
All right, I'll ask. So, for Connect, like I get this for things that can run Consul microservices and things, but let's say I have things that can't run Consul, like RDS and AWS or something like that. Is that something that you can jury rig, or is that just up to IBM and my permissions?
Yeah, good questions. The question was about external services in Connect, and I don't know if we published the guide yet. So we wrote a guide to do that. We are recommending, you could run the proxy on another machine. So you could run the proxy to front that RDS service on another machine. There's obviously a bigger performance penalty in that case because it has to hop across a real network, but you could still get end-to-end Connect that way. We're also working with some of the cloud providers right now. It's really early on, so no timelines or anything, but we're working, and I won't tell you which cloud providers, but we are working with some cloud providers right now to bake the Connect protocol and image into their network interfaces. And so for things like, it sounds fancier than it is because their network interfaces are basically just a regular, I mean, it's SDN, so it's just like code running down there. And so for things like, theoretically, again, not saying this specific service, but for things like ECS and Lambda and those types of services, we could just make Connect invisible to you. We could just like front the network interface with Connect for you that's attached directly to the machine. That's a longer period of time in the works, but that's how we would. So one hand, sidecar proxy on another machine close by, and then the other hand will native network interface stuff. Luke?
You briefly mentioned serverless.
Yep.
I know you were talking about that, but I just wondering your opinion on where you think that's going to go and how the HashiCorp tools might fit into that.
Okay. I'm trying to figure out how to answer this as quickly, I guess. So, I mean, I think serverless is interesting. Actually, I did a Q&A here about a month ago where I got asked this question where I gave the long form answer. So look at like replicated Q&A and find it in the 2 hours. But my basic opinion is that it's interesting, right? And it's interesting enough that I'm watching it, and also like we're trying to enable it in a lot of ways where it makes sense. It's so early that like for the way we sell software, like not even hiding anything, 0 users are even care about it at all. 0 customers even care about it at all. So it's not a commercial priority at all for us, but we do like stuff like Connect and working with people like Lambda, again, not saying it's Lambda, but working like that is because we want to make it work. I'm also working with some of the serverless framework developers to integrate Connect and some other stuff, not just Connect, directly into it, because it's interesting. It's like it's how I help your hammer be better. Okay, here you go. Like, we're toolsmiths, that's what we do. So like, let's make the tool better. Let's enable it for these different use cases and see where it goes. I think Nomad has a lot of interesting use cases with serverless. I mean, I think a really important part of serverless is the performance aspect of it. And so you'll be able to bolt on something like OpenFast or something onto anything, pretty much. Like, that'll work. But I think when you get to the dream of serverless being that you want as small of a Slack pool as possible, and you want those things to be scheduled, start up, and respond as quickly as possible, the limiting factor in there is going to be the scheduler, for sure. And I think that's a place where Nomad has a huge opportunity because we schedule so quickly. And so we're playing around with what scheduling functions would look like in Nomad too. So it's interesting.
These like crazy cold start, like they will ping your Lambda to keep it up, so it's like a fast cold start. So.
Yeah. I think we could be smarter about that. I mean, I think even the cloud providers will get smarter about that. It's just we're in the caveman days of serverless right now. So yeah. Any other questions? Cool. All right. Well, okay.
So are there any other particular problems in this space that we don't address that you find interesting?
In what space? In
like
the whole?
Just in the
whole?
distributed computing space that, they're kind of interesting problems to solve.
There's a lot. I don't know. There's none that like I'm like super passionate about. I think if we were super passionate about it, we would have done something. But I mean, I think the observability stuff's super interesting. It's just I see a lot of people gravitating towards like tracing and stuff, and I feel like they're doing it. I feel like tracing makes a really nice shiny demo, and people are gravitating to it way. They're running before they can walk. And it's sort of like if you're tracing, like I said before, you have some of this basic service mesh stuff figured out, I think you're going to shoot yourself in the foot one day. And so I think it's really exciting, and I'm excited watching these projects come out, and some of the standards like open tracing are really important, but I don't know. It scares me of how people are looking at it. Yeah.
Just a question, about the strategy of your product. Have you considered building like a single pane of glass type application that some of the big, software companies who did like a lot of applications and, basically building a console where a lot of products can be integrated and basically in quasi drag and drop fashion build the configuration then can be released to particular system engineers or cloud administrators and configurators who fill in with the details. But basically, somebody like an architect or maybe even a business owner who wants to kind of technology savvy to some degree, kind of wants to say, this is what I want to build through that single pane of glass without maybe details of Terraform or Vault or whatever, but just kind of said, this is the high-level architecture, and it will generate templates that will be filled in by, specific implementers.
Yeah, so I think I have a couple opinions about that, I guess. I think that's where you head to inevitably. That's where we'll all end up, I think, eventually. But I also think that I often hear that asked by a lot of high-level architects and stuff, but I think it's sort of you're asking for a bit of a silver bullet, because the reality of the company, it's sort of you can't have your cake and eat it too. The people that are asking for that are usually the big companies, and the big companies also are usually saddled with a ton of legacy. So so when you ask for this package where you can define all this stuff, you end up wanting opinions, but then not tolerating opinions at the same time. So you're kind of asking for both. And so you end up shipping something, and I'm saying shipping something because this is one of the first things we did commercially, and we just pivoted away from it. Because you end up shipping something, and everybody's like, great, you're almost there, I just need this one tiny thing. But everyone needs that one tiny thing, because they need to fit this legacy into it. And so I think that what we want instead is to give people these building blocks and have standards emerge from the popular use cases, and then sort of keep making the box smaller around them and pushing them towards the right direction, rather than trying to get where they are now and converting it. Like it requires someone to rewrite, right? And you can't ask someone to rewrite fast. So we're trying to support that while also giving them like the right tooling for if you build everything with HTTP APIs or gRPC APIs, then we could give you one-day tracing and all this stuff. But tracing won't work with your UDP-based protocols and things like that. So we can't give you the opinionated box without telling you rewrite that. And our opinion we won't tell you to rewrite anything. So we're going to support that too. So we'll see. But right now, I don't think it's reality. Oh yeah.
So you have a lot of stuff with Kubernetes, which is pretty awesome. That you kind of touched on.
Cool.
But there was talk about Knative. What is the roadmap for that? Or any discussion around that?
For Knative, it sort of falls into the serverless bucket, whereas like we're watching it, but I think we have enough catching up to do in terms of the Kubernetes integrations that we'll look at Knative a little more closely later. All right, I'll stick around, so feel free to catch me. Thank you.